Hi, we are going to look at the solutions for test review number 3 in this video. All right, so problem number 1 is an approximation problem where we are asked to approximate the value of the integral of e raised to the power x squared over 2 on the interval from 0 to 2. We are going to do our first approximation using the midpoint rule with n equal to 4. So I will start by just putting a number line out here and just noting the 4 equal subintervals that are formed along with the midpoint on each one of those subintervals. I'm also going to calculate delta x, which in this case would be 2 minus 0 over 4. So delta x, the size of each subinterval is 1/2. All right, so m sub 4 will be equal to delta x, which is 1/2, times e raised to the 1/4 squared over 2 plus e to the 3 over 4 squared over 2 plus e to the 5 over 4 squared over 2 plus e to the 7 over 4 squared over 2. You can evaluate this on your calculator by hand or either using your Riemann sum program. I get 4.58234. Note that the problem did ask to round our answers to 5 decimal places, so please do pay attention to those rounding instructions. In number 2, we are going to do another approximation, but this time using the trapezoidal rule. So again, I'm going to just jot down my number line here and note that the interval from 0 to 2 is already subdivided into 4 equal subintervals, making 0, 1/2, 1, 3/2, and 2 my sample points for the trapezoidal rule. Again, delta x is equal to 1/2. So t sub 4 will be equal to 1/2 divided by 2, that's delta x over 2, times e raised to the power 0 squared over 2, plus 2 times e to the 1/2 squared over 2, plus 2e to the power 1 squared over 2, plus 2e to the 3/2 squared over 2, plus e raised to the power 2 squared over 2. My evaluation here that I get is 5.02831. In number 3, we are again going to approximate the same function, but this time using the Simpson's rule with n equal to 8. So again, my number line from 0 to 2 has been divided into 8 equal subintervals, and so all of the sample points are noted. I am going to just recalculate delta x here because my n value has changed, so delta x will be 2 divided by 8, so 1 over 4. So the Simpson's rule with n equal to 8 is going to be 1/4 divided by 3, delta x over 3, times e raised to each one of those sample points squared over 2. So I get e to the 0 squared over 2, plus 4e to the 1/4 squared over 2, plus 2e to the 1/2 squared over 2, plus 4e to the 3 over 4 squared over 2, plus 2e to the power 1 squared over 2, plus 4e to the power 5 over 4 squared over 2, plus 2e to the power 3/2 squared over 2, plus 4e to the power 7 over 4 squared over 2, plus e to the power 2 squared over 2. And again, my evaluation here, and I used my calculator with the Riemann sum program, is 4.73100. All right, in part 4, we're asking you to simply use your calculator to evaluate this integral so that we could have some value for comparison. When I evaluate on my TI-84, I get that the integral value is 4.7289077786. So the only thing for me to do is just to round that value to 5 decimal places. I get 4.72891. All right, so problems number 5 and 6 want us to use an error-bound formula to calculate the maximum error when using the trapezoidal rule and n equal to 4. So we will start by finding the value for k so that we can plug that into the error-bound formula for error of trapezoid. So in order to find k, we need to find the second derivative of the function. So again, let's just note our function f of x is e to the x squared over 2. So the first derivative will be x times e to the x squared over 2. So I use the chain rule here. Derivative of the outside is e to the x squared over 2. Leave the inside alone. Times derivative of the inside. Derivative of x squared over 2 is just equal to x. So for the next derivative, the second derivative, we're going to have to use both the product rule and the chain rule. All right, so by the product rule, derivative of the first, derivative of x, is equal to 1 times the second, plus the first, which is x, times derivative of the second, which is x times e to the x squared over 2. So a simplification here gives x squared times e to the x squared over 2. I would like to know what the maximum absolute value is of this function on the interval from 0 to 2. And the easiest way to tell is just to graph it. So here is a graph of that second derivative. And we can see on the interval, and I'm going to highlight the interval from 0 to 2, the function reaches its absolute maximum value right there. So we see that that absolute maximum value is reached when x is equal to 2. And that y value, that is my k value. So k is equal to the second derivative evaluated at 2, which I get to be equal to 5e squared. All right, so in number 6, we want to find the actual error. So this is the easy part, pretty much plug and chug. The formula for the error of trapezoid, we know that the error will be less than or equal to k times b minus a cubed divided by 12n squared. So that's going to be 5e squared times 2 minus 0 cubed over 12 times 4 squared. I get 1.5393867. Make sure on this previous problem, when you enter your answer, to round it properly to 5 decimal places. All right, so the last problem here on the approximation problem wants to know what value n should be if the error of trapezoid is to be less than 0.0001. So what should I choose my n value? So here I'm going to rewrite the formula for the error of trapezoid so that I solve for n. We see that n will need to be greater or equal to the square root of k times b minus a cubed over 12 times that error, that desired error. And again, I'm going to plug in my values. So my k value is still the same as before, 5e squared times 2 minus 0 cubed divided by 12 times 0.0001. So when I evaluate, I get 496.288. We know that n has to be a whole number. 496 will be too small, so I will always round up to the next integer. So n will be equal to 497.